All right, welcome to today's community conversation. My name is Sean Hurley, and I'll be your host. We're joined by Jacob Small and then guest speakers Stephan and Tomasz. And this is about Dynamo and robot structural analysis and advanced steel. It's going to be a good, informative, fun time. So let's kick it off. Next slide, please. Community conversations are virtual meetups featuring expert speakers from across community. Sessions range from deep dives, tips and tricks, and live demos on products such as AutoCAD, Revit, Dynamo, Fusion 360, anything. We're open to anything if you want to submit your own community conversation. It's emerging trends, career stories, industry, all level, beginner to advanced. Now for the fun slide, Jacob. I laugh at this all the time. It's just the safe harbor statement. And what this states is if we say anything forward-looking, future product, that kind of stuff, we're not making any promises or dates that it's going to happen. It just, you make your purchasing decisions based on the products as they ship today. So that's all I need to say about that. Next, please, just some ground rules or norms. Everybody's line is muted to kind of reduce the background noise. We are recording this. So there'll be a link in YouTube or a video in YouTube, as well as on the event page where you registered for this to watch this. To ask questions, because this is a conversation, use the Zoom raise hand, the little hand thing down in the bottom right, and we'll call on you to unmute, or you can ask in the chat and we will take those as we get pauses in the session. So next, please. Again, I'm Sean Hurley, Autodesk Community Engagement Manager. Happy to be here. I'm a geeky technologist in Bend, Oregon. And I'm taking this time to not play with AI generated art. I'm addicted right now.
You absolutely are. And I am Jacob Small. I am a technical consultant focusing on generative design for Autodesk. I describe myself as a Dynamo Forum junkie. I'm always looking to get involved with the Dynamo community and help other users grow on their journey. I'm based out of Boston. Sola Moore was hoping to be here. We actually had plans on both of us being in the same conversation again. It's been a while, but sadly he had some personal stuff come up, so he's not here. So it is my pleasure to present Tomasz Fudala and Stephen Gumpert. Tomasz, do you want to introduce yourself to everybody?
Sure. I'm Tomasz Fudala. I'm a structural engineer and I'm a BIM enthusiast. I have been working for Autodesk for almost 15 years. I'm the technical marketing manager for structure, and I'm based in Poland, in Krakow specifically.
All right, Stephan?
Nice. Yes, so my name is Stephan. I am based in Brisbane, Australia. So I'm a technical specialist. I also manage a team scattered across ASEAN, India, and while working in ANZ as well. Structural is my background. I'm not a structural engineer, but I'm a structural draftsman. Deal a lot with fabrication, done a lot in automation, obviously. A bit of a programming geek as well, but yeah, nice to be here. Thanks for having me.
Awesome. All right, so we've got, this is the 32nd in our series here, and we were just doing a bit of a chat here with Sean before we got started. We've got quite a long back catalog here, so we're really excited to be continuing and finally getting to talk about the structural aspects of Dynamo and how Dynamo can interact with robot structural analysis as well as advanced steel. So our agenda for today is just that. We're going to start things off by talking about Dynamo's interaction with robot structural analysis and then move into advanced steel. I know I have usually our live demonstrations up at number 2, but we're actually going to have 2 live demonstrations today, I believe, one for each, which will be really good, followed by question and answer. So with that said, Tomasz, do you want to take over the screen share and teach me some cool stuff on robot?
Sure, thanks, Jacob.
Awesome.
Okay, so can you see my screen?
Yes.
Okay, let's get started. Let's talk about computational design for the structural engineering industry. Let's talk about Dynamo and Robot structure analysis professional specifically. Currently, structural projects are getting more and more complex and demanding. Engineers are often confronted with increasingly complex architectural forms, which makes modeling structures for analysis and optimization very time-consuming, thus lengthening the design process. Structural optimization is an iterative process. Engineers analyze many design options to find the optimal one, and engineers are becoming more involved in form definition, as the optimization of material and strength often comes from multiple analysis of many form variations, one of more which is ultimately proposed to the architect. An answer to the study of complex architectural forms, we all know, is Dynamo, and architects often benefit from computational design when modeling complex shapes of architectural objects. So engineers should not be left behind, and they should also support their design processes with this technology. Architectural shapes and curves can be converted into Dynamo geometry, which can then be used by engineers to create a structure model, accelerating and improving creation of physical and the analytical models. So now let me briefly describe how Dynamo can support design automation and computational modeling workflows for structural analysis and the design of concrete and steel structures. Dynamo lets structural designers and engineers create visual logic to explore parametric designs, design options, and automate a bunch of tasks. It helps them to solve challenges faster by designing workflows that drive the geometry and behavior of design models. Since last year, Dynamo can be integrated into Robot structure analysis professional. So no more Dynamo Studio to connect those two products. You can do this by installing the Dynamo extension for Robot structure analysis available through the Autodesk desktop app. And once it's being installed, additional option will show up under the add-in menu. Dynamo for Robot structure analysis enables the analysis of more design options and more complex structures. The updated structure analysis Dynamo package is pre-installed with this extension. So if you use that package before, you may notice that some of the package notes have been recently updated, and the structure of those nodes has been reorganized. The current version of Dynamo extension for Robot contains Dynamo Core 2.13. So let's talk about what you can find in the package. This package contains a collection of Dynamo nodes to create analytical model geometry in Robot. You can create analytical nodes, analytical members, and panels. Some basic standard attributes can be assigned to the analytical elements as well, such as section member profile, section gamma rotation angle, member and releases, panel thickness, etc. This package also allows you to create structural loads. So we can define load cases, apply structural loads to the structural elements and assign them to those load cases. We've got nodal, uniform member, uniform panel loads, which can be automatically added through respective nodes. And finally, you can find some nodes to manage calculations and retrieve structure analysis results. Now let's explore the automated structure analysis workflow available within Dynamo and Robot. Okay, so based on the Dynamo, the parametric Dynamo geometry, you can create analytical models. Then you can apply sections, define different boundary conditions such as supports and releases. And like I said, you can automatically apply structural loads. And one of the benefits of this approach is the fact that values of structural loads recalculated every time when the structural geometry changes. So no need to manually, calculate appropriate values of loads that need to be assigned to specific members of your structure. You can build that logic, and those things, happen automatically. When the analysis is done, you can review the results in the robot structure analysis environment, or results can be reviewed within the Dynamo environment, using some dedicated Dynamo nodes to explore those results. The analysis results available in Dynamo can be then used during the code checking process in the Dynamo environment. For example, you can build some formulas. You can have some formulas created based on the building design codes that would take the analysis results as input parameters, and then you could continue that structure analysis workflow and extend that to code-based design workflow in Dynamo. A rich library of sample Dynamo files is provided with this package. After installation, you can find them in the extra folder. You can also find tutorials corresponding to some of these sample scripts in the same folder. If you are interested in the automated structure analysis workflow, and you have never tried this workflow before, I strongly encourage you to get started going through these materials first, because there is a lot to go through, and you can take a lot from that. Okay, so Robot has many capabilities in analytical modeling, structure analysis, and code-based design. The nodes available in the package contain only a small fraction, a piece of Robot's capabilities. Moreover, using the package nodes gives you the ability to develop Dynamo graphs that create your structures from scratch only. It's a kind of limitation. So you will not find nodes that would allow you to select the existing models to retrieve some data, boundary conditions, and add some additional elements in the context of existing structures, in the way how it can be done in Dynamo for Revit, for example. But no worries, you are not limited to what is offered by the structure Dynamo package nodes. Using Python scripting, you can get access to other RSA robot features via Robot API. So you can add a reference to the Robot OM DLL file and get access to the Robot API. Then using the Python script node, you can easily build scripts developing some missing capabilities. In other words, this approach will give you the ability to modify existing elements, as well as use classes, methods, features that are not covered by out-of-the-box Dynamo nodes. So if you are a Python coder, you can extend this functionality according to your preferences, according to your needs. The robot structure, the robot's software development kit contains a wide range of tutorials, user guides, and code examples covering all aspects of robot structure analysis API. And the robot structure analysis SDK is available with the installation of Robot. So if you're interested in programming. Okay, so let's start our demo part. The first thing I'm going to show you, it's a short video that covers two example structures that would be quite difficult to model in Robot. And the process of modeling them would be very time consuming. So the first model is an outcome of one of example scripts provided with the structure analysis package. As you can see, the model is generated and calculated in Robot. The second structure, this spatial truss, would be very challenging too, especially when we would need to make a few iterations with its geometry, analyzing a few design options one by one to find the optimal one for our roofing. So with that being said, let's jump into a quick demo of the automated structure analysis workflow. So let's move to robots, and let's spend 10 minutes exploring some nodes and the workflow I just described. So let's start an empty project. Let's run Dynamo. Which can be found under add-ins as an additional feature. Okay.
Tomasz, while you launch Dynamo, can you just answer a quick question? Is the Dynamo for Robot integration sort of in process or out of process? Meaning, when we hit run on Dynamo, is that going to lock up Robot, or do we have to wait for Robot to free up?
Oh, no. So it can be started if we don't have that RSA. If we don't the RSA application open, that should start Robot. Yeah.
Okay.
But the workflow is you have your RSA open, and to make sure the connectivity is the right one between the Dynamo environment and RSA environment, I would rather recommend to make sure we start with RSA first, then hit Dynamo feature in RSA and start scripting.
Makes sense. Thank you.
Let's open an example script I put together for this webinar, and so to explore the flow we have in this workflow. It takes time while I'm projecting, as it shouldn't take as long. Okay, so the first stage. So this is a Dynamo script, a very simple Dynamo script I'm going to walk you through to show you some stages of the workflow, some necessary nodes that definitely you will be using trying to implement, these automated structure analysis workflow. The first stage of this workflow is the definition of a parametric structure in Dynamo to easily manipulate input parameters we've got here to create various design options in Robot. So let me switch to automatic to make sure the script is executed. Yeah, this is a fairly simple structure, nothing sophisticated, but just to show you the concept. So everything is, I'm not going to explore, how this structure behave if I, manipulate my, parameters, but the structure is, fully parameterized, to reuse that definition if we decide to, change the spacing between frames because of the result of structure analysis, etc., etc. So we've got Dynamo geometry, that is a necessary, thing to have, and then we could actually quickly, start, generating the analytical objects in RSA. In here, you can, under add-ins, you can find the structure analysis package I described in my slides, with all those nodes that support analysis, modeling, creation of loads and exploration of results, right? So right now I'm interested in creation of analytical models. So here we have 3 groups to define nodes, members, and panels. And when it comes to, in my structure, I have only members, right? So stick elements. So I have 3 different options to choose from. I can define my analytical members using Dynamo lines, Dynamo points, or leveraging some existing analytical nodes. In my case, I have analytical bar by line used in the script. But before I generate, the script, actually, I want to make sure that all sections that I will be applying to the structures are already loaded. That's quite important to avoid situation we have things generated, then we start, assigning attributes. Sections, and those sections are missing in the software. So that's why I created a kind of proxy node to make sure those sections are loaded before we create any kind of analytical geometry and start assigning those sections. So right now, this node shows you that right now I have only 3 elements, 3 sections available. We can also check this here in software. These are all the sections I have right now loaded, but the process of loading those sections can be automated too. So if you have a list of sections you want to have loaded automatically, you can just create a list of strings with appropriate, valid names of labels, and those sections will be automatically loaded into your project, and they are taken from the current database that is set up in your RSA project. So if I open this dialog box, you can see now we have all sections loaded into the current project that we're going to use in our script. Okay, so now we are ready to go and generate analytical members. I'm using this, 6 times as I want to have as an output. I want to have things already sorted and grouped properly. So I want to have my analytical columns as an output of the first node. Here I have my rafters, my beams, etc., etc. So let's check this out in RSA. So we have this geometry created, but those are just analytical lines without any properties. So if we have a look in the object inspector in the properties tab, you see those elements, they don't have any sections assigned. There is no material assigned, nothing. So this is just geometry, analytical geometry, but we are ready to apply some sections right now. So let me switch to manual and unfreeze those 6 nodes quickly. And hit the run button. Yeah, so all those sections have been right now assigned. You can you can quickly see the outcome. switching off the display of sections, or making a selection and exploring those things in the properties window. By default, we've got material edit. It's a steel. It's a default material you right now set up in my current project. But like I said, we can define a bunch of different attributes. So I can automatically assign in proper locations supports. I can set up the right material I want to use for my structure. So let's say it will be S355. I can also set up releases at the ends of specific structural elements. In my cases, I want to have pin-pinned releases at the end and at both ends of my bracings, X and V bracings. So let's run and let's see what happens. Yeah, right now the material has been changed, so all elements have the updated material right now, the one I specified in my script. As you noticed, we've got supports edit, and if I turn on display of releases, you'll see them at the ends of my bracings, right? So all those things can be set up automatically. We have a limited number of attributes we can assign using those out-of-the-box nodes. However, you can do your Python scripting and you can add a bunch of additional, capabilities. So you can manipulate any kind of, attribute. Okay, let's move on quickly. Whoops, sorry. Okay, so the next thing is adding loads. So here in my example, I have two kinds of load cases. The first one is it's a special load case for self weight. So automatically to this case, the entire self weight of the structure will be added, and I added additional load case, snow load case, and here let me remind you what I already mentioned. So if you apply structural loads automatically using Dynamo, one of the benefits of this approach is the fact that values of structural loads can be recalculated every time when the structural geometry changes. By default, in the design code, you can find some snow loading that are area loads. For example, this is 1 kilonewton per meter squared, but we don't have any planar objects to leverage that value. So we need to calculate load distribution and based on the geometry of our structure. So I would like to apply, my snow load to all purlins. So so I can calculate the right linear loads using frame widths, using number of purlins, their density, the spacing between them. So if I click run button, you will see the outcome. We've got two load cases defined. So let's have a look at the snow loads. Take a look. They have been generated automatically. The values were calculated based on my area load and the distribution of my purlins. So for example, right now, if I change my mind and I want to decrease the spacing between my purlins. Instead of having 5 of them on one side, I want to have 6 of them. And I recalculate my script. The entire geometry will be updated. Some additional purlins will be added. The loads will be recalculated and reassigned. So right now you can see, the values of loads have been, automatically updated, reflecting to the geometrical changes. That's the beauty and the power of using that, automated workflow for analytical modeling. Let's go back. Let's rerun. And the last thing is I wanted to highlight in this workflow is the process of running calculations and exploration of results. So we have this node gives you the ability to run calculations from within Dynamo. And as an input, we need to provide the analytical model definition, the entire analytical model definition. In other words, all members. So my first item here, let me unphrase this. So the first item in this list is a list of all analytical members, 142 of them, as an output of the node where I was setting up, my material for my structure. And the other 2 items are load cases, those 2 load cases that are taken into account during calculations. So let's run it. And let's, before I do this, okay, let's run it. I started the script. So you should see in a second that my project, did I run it? Yeah.
Tomasz, while that runs, there's a question in the chat, which is a pretty good one and interesting one, I think.
Yep.
So Marcelo Scambarelli, sorry for butchering your name, Marcelo, wants to know, so all the functionality is there, but not necessarily all the nodes. So are there any samples of code out there to sort of get a better idea of how to make custom nodes for Dynamo for Robot? Any packages, Python based maybe, or even open source zero touch nodes that people could refer to?
Unfortunately, we don't have such examples, but if you are familiar with Python scripting, just go through Python scripting, or you created some zero touch nodes for Revit. Just go explore the Robot API documentation and do it in the similar way. The process is pretty much the same. If you don't want to play with zero touch nodes, then just use Python and do the same. The key is to understand the RSA API and how to the rest is the same as in the Revit case.
All right, thanks. Hopefully,
Yeah,
Marcelo,
so,
hopefully that covered everything for you.
Marcelo, reach out to me if you have any detailed question. I can try to answer. If I do not know the answer, then I find the right people. So in the meantime, the structure was calculated, and so we have this notification in the title bar that results are available, and we have now the workflow says that we have 2 options. We could visualize results in form of diagrams, in this case, for specific internal for specific internal forces for MY moments in RSA, or like I mentioned, we can do the same in Dynamo. So we can retrieve some maximum, minimum values. There is by the way, there is a bunch of nodes to explore results for members. So for bar displacements, for bar forces, bar stresses, and we can also visualize the internal forces in form of diagrams in the similar way as we do in RSA. So let's change the member. I want to explore results, and let's recalculate. There we go. So we've got MY, moments, internal forces, and FZ forces as well, shift forces. So you can take those numbers, data, and continue developing the logic for code-based design, from this point. So with that, I would like to hand over to Stephan, who will walk you through Dynamo and Advanced Deal. Thank you.
Awesome. Can you hear me? Can you see my screen?
Yes.
Yes, we can.
Awesome. Okay. Yes, welcome. So thanks for that great introduction. I learned something new myself there. It was good. It's always good to see somebody else doing something different to what you're used to doing, because there's always something new to learn, right? So from my perspective, we're going to look at Dynamo with Advanced Deal, but we're going to look at it from more of a fabrication piece. Obviously, Advanced Deal's bread and butter is fabrication. So looking at the fabrication piece, I always say it's taking those next steps to automation with the 3 M's. And it's a bit gimmicky, but it's a way to describe what we're talking about. And my mantra, and has been for many, many, many years, is I want to work smarter, not harder. And so hence why I've got the techie background, the programming aspect, and of course the Dynamo side of things. So what do I mean by the 3 M's? Well, we're talking about make, modify, and metadata. And by this, we're talking about obviously the creation of objects, manipulation and modification of objects, and how to utilize the data that sits inside of these objects to help do whatever it is that I need to do. As I said, it's more focused around the fabrication piece. And with fabrication, there's obviously a lot more information that needs to be stored in these objects. There's checking that needs to be done during the creation process, which again, Dynamo can facilitate the ability to create rules to go and check certain things during those modeling phases. So, I mean, the big question people always ask is, why would I even explore Dynamo, right? Why? Or why automation in general? And I mean, the obvious two for me are efficiencies and, of course, the removal of those human errors. And until someone actually gets involved in automation, people don't actually understand the, I guess, the amount of time saving that can be done when it comes to automation, especially, using Dynamo. I think that the reason Dynamo is such a great tool in all of our products is it's that in-between piece for those non-programming individuals. So, I might be a draftsman, I might be an engineer, but I might not have programming background. But from a logic perspective, I can string logic together, right? So for me, it's that go-to space for those people who don't want to learn how to write code, but want to take their design or their modeling to that next phase. Of course, as Tomasz showed, you definitely can still include this in your processes, and the nodes can be extended, of course, as well. So if we look at all the Dynamo nodes that exist inside of Advanced Steel today, I think we're topping at about 200 nodes. So quite extensive. They're all posted on GitHub. It is an open source package. So if you were looking to extend and write your own nodes, the ability is there to go and create your own nodes as well. If we look at the make side of things, it's obviously, or if we look back at the 3 M's, make means creation of those basic advanced steel objects, the beams, the plates, the grating, whatever they may be. The creation of modifications, as in holes, cuts, etc., or the creation of supporting objects like grids or cameras. So there's lots of different options in that space. If we look at the modification side of things, or modify, it's being able to select the objects, use utilities to I guess modify those objects, edit the properties of those objects, which obviously leads us on to the metadata side of things, because metadata is actually part of most of these processes. But for me, the big standout one, and we'll talk about this a little bit more, is about how to use that metadata to, I guess, take it to that next level, or take it to another file format. And I'll show you what I mean. So what I've actually done is I've flipped my slides on their head, and I start with metadata. And there's a reason for that. So when we talk about the data that exists in our objects themselves, you know, we want to add data, we want to import or inject data, maybe change existing parameters or properties of objects, or, and this is the big one, set properties during the creation. And ultimately, as I said, the extraction of data. How many times do I get questions from customers, and there's heaps? I want to export a certain type of XML file, a new format of a CSV. You know, I've got a specific fabrication machine, just needs a basic CSV file. How can I do that? And this should give you the ability to do that, right? So the data component is massive, right? If we think about the properties that exist inside of Advanced Steel, there is a property object or property node for every object type, right? So the thing to look out for is this specific object type and properties type node, and it exists throughout the tree. And when you get this tree, you get this, once you select this node, you get this node that comes up with the drop-down list with all the different properties that exist as part of that object itself. So for example, you know, having text-based nodes or number-based nodes, say, for example, decimals. So in this case, the length of a plate, or if we look at integers, looking at the explicit quantity of an object. Maybe even extracting points. So being able to extract the center point of the plate, or the coordinate system of the definition of that plate. So now we're looking more into the properties once the object's been created, or when I've selected a specific object and I want to do something with it, right? And of course, the plane where that plate might be defined. Now, when you look at the last three, they're inputs into the creation of new objects as well. So being able to extract information out of old or existing objects and reuse that data to create new objects, I think is also quite handy. And this is the reason why I put metadata first in when describing the 3 M's. Ultimately, it's using a combination of those properties and selection nodes to be able to manipulate either existing objects or, as I said, create new objects, right? So you can see there's a bunch of property nodes where you can get a property by name or value, set or get properties. Some properties are read-only. This is not documented, unfortunately, but you'll get to learn them over time. If you get stuck again, ping me if you need some help. So if we look at the make side of things, and this will show a little bit more on what I mean when it comes to those properties. So, you know, being able to create beams, plates, and you'll notice here the plate properties snippet where I took it before, gratings, and you can see bar grating, standard grating, variable grating. And I didn't expand these out because the graphic would have just gotten too long, if you like, right? But you can see for each of the types of nodes, like plates, for example, there's multiple variations, as in multiple options on how you might create those. So here you can see rectangular by coordinate system. So I'm extracting that polygon from that other object and the coordinate system and combining those two, and to be able to make new objects themselves. The concrete elements can be modeled through Dynamo, and miscellaneous objects, so grids, cameras, special parts, can all be modeled using Dynamo or manipulated and modified, right? So you'll see some of these objects, for example, have a series of modification functions that exist as well. So for example, you know, setting the XY extents on a camera, or manipulating that existing camera accordingly. So examples of where I would use make, anywhere where we have repetition, right? Stairs, trusses, frames, chutes, bins, hoppers, plate work in general. This is all very detailed screenshots you see here, but the example that you see here is item 1 and item 2 are identical in that they are the same type of truss that's created in a conveyor from one to the next to the next. The difference is this might be a 12-meter truss and this might be an 18-meter truss. So therefore, using that Dynamo ability to create repetition, but it's just shorter or a little bit longer or whatever, to give us that automation piece. Now, where does the metadata come into play in the creation of objects? Well, each object has an option for parameters, and you can pass these additional parameters that we talked about in the metadata as a list to the creation of these objects. So rather than extend, and I did originally when we started extending these nodes, we started making nodes with masses of lists of parameters, all in the node itself. But what we've quickly looked at, the amount of properties that actually can be passed to these objects during the creation phase, the amount of nodes we would end up having to create and maintain would just be not usable. So what we did was we created the ability to create these additional parameters that can be passed to each one of the basic nodes to allow you to pass almost an unlimited amount of parameters to those objects during creation. So whether it was a straight beam by line, a poly beam by a poly curve, a plate by a polygon, doesn't matter. All of them have the option to provide extra parameters. So you can see here I've created a bunch of parameters and then passed it to the create instance of that node to be able to pass extra parameters to that object. So if we look at it in this example here, so technically in this case we're actually passing 3 extra parameters to the creation node itself. So in the first instance here, we're passing the name and the type of the object, right? So you can see we're taking the equal angle type, the size of that, passing it here to the create section string node. We're saying that we want to create the profile name property and then combining the output from this node and this property name as a property, and then passing it as the first entry point to this list. And then if we go to the next one, we're creating the model role. Again, we're selecting the type of property from the drop-down list, passing it as the property name, the value that needs to be stored as part of that property, and adding it to the list, and so on and so forth. So you can see, and in this case, material itself. So you can see the amount of properties you could pass on creation of these objects. It's not unlimited because there is a limited list, but technically it's up to you on how much you want to automate as part of this process. And as I said, at the end, we put this into a list itself. Why? Because this list actually has to be passed as a list, or all those properties need to be passed as a list to that creation node. Hopefully that makes sense. And you can sort of see now why I put the metadata side of things at the beginning. And originally when I had my slides created, I had it in the same order that I started with. But yeah, and we'll follow on to the modify side of things.
Stephan, just a quick time check. We only got about 2 minutes left before we have to start wrapping up, unfortunately. I think we might set something up to maybe have you back to go over some of this other stuff, because this is really good.
Sure, definitely. So from a modification perspective, you know, obviously cuts, copes, holes, polycuts, anchor patterns, shear studs. I mean, there is so many things. And again, you notice here, anchor bolt properties, right? There's lots of options here, right? Grating, concrete elements, modifications of those elements, and then, you know, whatever that might be, am I adding an extra hole to every beam that I've selected 35 millimeters in from each end, right? Or 1 inch, if we want to talk imperial. Am I changing the material grade of all the objects that don't meet a certain criteria of a property, right? Or am I adding in a text value into one of these areas, right? So I was going to go into a live demo. Do you think maybe we should pause there? And
yeah, I think that's probably a good stop point. And I will quickly take over the screen share.
I mean, happy to come back and do a bigger, deeper dive if you like, because there's plenty to show and talk about for sure, especially with 200 plus nodes sitting in that space. Yep. It's not exactly a 5-minute discussion.
No, definitely not. So I did want to touch on a couple of questions that we had pop up in the chat. The first one was from Edwin, who asked, is there any plans in the future to integrate optimization options, like optimizing the form and members based on the loads and boundary conditions? And Edwin, that's a great question, and you might want to attend, and Tomasz, I'm going to let you weigh in on this too, but you might want to attend the coming sessions on generative design, because there are ways that you can start to hack those two pieces together and get them to work. So Tomasz, do you have any further color commentary there?
There are no specific plans on RSA side, to extend, this package functionality. So it's not on the roadmap when it comes to, pure RSA. Yeah.
Okay. And then there were some other questions on the advanced steel side in terms of how to make particular plate types and shapes like that. Stephan, to your point, 200 nodes.
Unfortunately, no, not yet. So the folded plate option was one that was originally on the list, but those 180 nodes that we added that year, time just ran out, and unfortunately there is a deadline for these code to be written. So yeah, currently not. But look, who knows what the future holds? But yeah, also happy to do. I mean, John's asked if we could do a dedicated session to advanced steel. More than happy to.
I've already got a note to talk to Sol about that and see if we can get something set up in our current roadmap for sessions we've got planned. So we'll be in touch, and we'll make sure to circulate that out to you, John, and others through the larger community conversations marketing machine, for lack of a better term. All right, so on that note, what is coming next? So we meet every 2 weeks, Thursday at 1 p.m. Eastern on the East Coast of the US. If you're elsewhere in the world, hopefully you can go ahead and do those conversions, and it's not super, super late for you like it is for Stephan at the moment, but there we have it. Now we do have a summer break coming for the month of July. Sol and I just both want to go out and see the outside and have some fun, so we're going to do that. But we'll be back in August talking about Dynamo's visual refresh, all the changes that have come in Dynamo 2.13 and some of the things to keep in mind there. We've also got coming up after that, we're going to be diving into generative design, starting with a special guest, John Pearson from Parallax team, who's a very active member of the Dynamo community, so really excited for that. And then picking up from there on September 1st, and then again on the 15th, but it's not written down yet, with Lily Smith to talk about from the generative design team, actually, to get a little bit more deeper into sort of the authoring of the tool sets and stuff like that. And then many, many more awesome things to come. Sean, over to you.
Thank you, Jacob, and thank you, Stephan and Tomasz. That was awesome. There's a lot of deep stuff in there. I mean, back in my history, I've done some structural. I've also done some bamboo structural analysis, so it was always fun. But it's neat to see how you're able to automate it, some of those simulations. I want to quickly go over, we got some resources for you, some community resources. Also to mention that when you exit here, there's a quick little survey, and I do mean quick. It helps us figure out what we should do in the future, what we're doing right, how we can improve, all those good things. But it's really quick and it does help us. So I have pasted a link. The recording will be on the event page as well as YouTube. And I'm going to give you some links, and I'll put them on the event page as well for community resources. Many ways to explore and connect in the Autodesk community, including the global network of user groups, the industry-focused communities helping your colleagues solve business challenges together, forums, Twitter, all kinds of good stuff. The Voices blog, which is customers. Anybody who has any kind of expertise in Autodesk products or industries is welcome to become an author on that. You can also become a community conversation presenter. So if you'd like to lead a session on something really special that you, or an industry or a talk, please feel free to reach out to me. There's also a link I put into the chat there on a forum. So many resources, but thank you so much for joining us today. And this is, like Jacob said, the last of the month, and then we got the month break. So I'm going to take a few days off. Maybe I'll probably just end up outside, but also playing with the AI again, Jake, to be honest.
I knew that was coming, Sean.
Yeah, I'm going to make, like, what happens if I put marshmallows with fungus and spiders? That kind of stuff. It's just interesting to see. But thank you, everybody, and we hope to see you again. There's a lot of new sessions on the calendar. If you look at the event page for community conversations for August, September, and October, and we'll be adding more and more as we go through the month of July, plus some replays of some greatest hits. So thank you.
Awesome. All right, thanks everybody, and thanks Tomasz and Stephan.
Yes, Stephan, thanks for being awake at 3 a.m.
All good.
All right. Cheers.
Bye, everyone.
Thanks, Dave. See ya.